Okay, so reviewing from last time, we're looking at some square roots and how to simplify radicals, right? So here's a couple examples of that. You can just put them on the back of your worksheet or in your notes, wherever you like. So when we're trying to simplify square roots, we're trying to take what out of the square roots, as much of what as possible. Yeah, like whole numbers. And what numbers do we target? And since they're square roots, we want to be thinking about what kind of numbers? Square numbers. So it might be helpful to write those down on the board. What's the first square number? 4. I mean, the first square number is really 1, but that's boring. It doesn't really help. The next square number is 9, yep. And then 4 times 4 is going to be 16, 25, 36. I'll just get them from there for you. I might miss one, though.
Next 81.
Thank you. Sweet. So those are the numbers we want to be thinking about when we're trying to simplify square root radicals. If we're doing cube root radicals, like we'll look at next week, we would probably want to think about some different numbers in terms of what will come out nicely as whole numbers, okay? So we've got 3 here. Are they like terms? Anything we can put together right away on this one, guys? No, like they're all different, pretty different, right? The nice thing is they might be like terms if we simplify them because the m's are all in each one, right? That's a good sign, but we'll see what happens. Okay, so 600, which square number do you think goes into 600? Remember, you can use your calculator to experiment.
Or you can use those.
Yeah, you should be using these though, but with your calculator if you're having trouble. 100 goes in though, that's pretty easy to see, isn't it?
Yeah.
So, let's see, we're going to write this then as, how do I write it? 100 times 6, exactly, and the m's still chilling. And then this one, 24. I don't think we need our calculator for 24. Do any of those go into 24? 4 does. 4 times 6. The m is still chilling. Good? 54. Any of those go into 54? 9 does. You guys said 6 times. I heard it. M is still hanging out. All right, why did we do that? Remember, the reason we did that is because now we have square roots that we can do, because they're square number square roots. Square root of 100 is 10, leftovers. Square root of 4 is 2, leftovers. 3, what's 2 times 3 then? 6, right? So we'll have 6, root 6. Okay. If you want to write another step there, go ahead. I think that's too many steps. I don't want to write that much. Okay. All right, do we have like terms?
Yes.
Yeah, what kind of like terms are they, if you wanted to name them? Yeah, exactly. They're root 6m's or square root of 6m. Good. So we've got 10 of them minus 2 of them plus 6 of them. I'm going to put my positives together first. So 16 minus 2 is 14 of the root 6m's. There you go. Now, they might not always come out to be totally like terms. I'm sure you guys probably have a problem or two, or you'll have a couple things left. That's okay. I tried to make most of them come out kind of nice, though. Right? Okay, this one just has one big radical, one big square root. We want to do the same kind of thing. Take as much out as we can. So 32, what do you think? 16? Yeah, I like it. 4 also goes in, but you want to take the bigger one out if you can, otherwise you're not going to be done yet. Big one is 16, that goes into 32. X to the 7th, I can write as x squared, x squared, x squared, x, if you want to write it out the long way. You don't have to write it out the long way, it's up to you. And I could do the same thing with this. How many x minus 3 quantities would I write out?
6.
Yeah, there's 6 of them there, but I want to break them into powers of 2, right? They're squares. So I could write out x minus 3 quantity squared 3 times if I wanted to. I'm going to do that without writing it out because that's just going to get crazy. So let's think about what the square roots of these are now. Square root of 16 is, of course, 4. The 2's leftovers, so I'm going to leave some leftovers over here, okay? So 2 is leftovers, 16 came out. Let's put some red things under the parts that come out. Does this come out? Yeah. This? 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 Okay. So that one's going to be leftovers. And these each come out. Square root cancels squared.
So that's what she said.
So the x, I don't want to write it that way.
X squared x 3x.
It's x cubed. X squared x is right too, Cody, but x cubed's the easiest way, right? Okay, so is this going to stay out or be leftovers?
Would it be leftovers?
I think the answer is this. There's no leftovers on that one. Why?
Just trying to.
You could write this as x minus 3 squared, like I said a second ago, times x minus 3 squared times x minus 3 squared, and 3 of them would come out. Does that make sense? Just like instead of writing this out the long way, the better way to write this probably, save yourself a little time, is to go x to the 6th x. And the square root of x to the 6th is x cubed. So the square root of this thing to the 6th is that thing cubed. Same kind of thinking. If this thing had been like to the 9th, let's pretend it was 9, then I'd want to write it to the 8th with 1 left over, and the square root of it to the 8th would not be cubed, but what? 4th power, and then we'd have a leftover inside. Okay? Why don't you guys try a couple of yours while I get a couple more examples ready? All right, so we're also going to look today at the issue of rationalizing. So you're going to see some division problems with radicals in them, particularly. So there's a special thing you need to realize in order to simplify radicals fully, and that's called rationalizing. So let me write down what the definition is for that. So rationalizing means that when there is a radical, a square root in other words, but any kind of root this applies to, left, any kind of leftovers in the bottom, the denominator, we need to remove it. And we're going to do that with a clever one. Okay, so some of these might need to be rationalized, some of them might not. Some of them might just come out pretty nicely, all right? So, if we want to square root 169 over 81, wouldn't it be nice if we could just like square root the top and bottom separately? Well, you can. It's that simple. So what do you guys think this would be then? Square root of 169 over 81 would be like, square root of 81 is, so 9 would go on the bottom.
Wasn't that 14 or 16?
13. 196 is 14. Nice. Okay, so that one came out easy. I don't have to worry about rationalizing it. Okay? The answer is 13/9. Much better to work with that than this.
That's it?
Yeah, that's all for that problem. I mean,
Oh, that's cool.
it had nice square numbers. So what about this one? I heard 4?
Top.
4 on the top. There's a negative there, so you know, just like past the negative, it's fine. 27, is that a nice square number?
No.
No, but
9 to go read.
yeah. Okay, so 9 square rooted is 3.
So
So 3 root 3 is on the bottom. This is an example of when you need to rationalize. Now I can't really explain why right now because you guys haven't done trig, but this is something specifically that applies to trigonometry. So it's just a habit we want to develop. Also, it gives us the opportunity to use a really powerful concept, which we use a lot, called a clever one. So to get rid of a root on the bottom, what you want to do is multiply by that same thing again. Except you can't just do that arbitrarily, and there's no equation here, right? There's no two sides. So the only way to make this legal, the only way to make that red thing legal, is to multiply by the only number that doesn't change your identity. What's the only number you can multiply that does not change your identity? 1. So how do I make this 1? that?
3 divided by 3.
This is just like a common denominator, right? It's kind of like when you do a common denominator, but you don't want to think about it like that. Think of it as a clever one, and you'll have dividends come your way in the coming years. Okay, so why is multiplying by that same thing going to help? Well, let's just look. Up here, it's still up there. It's okay to have them on top, though. We just don't want them in the bottom. Because dividing by irrational numbers, which like the square root of 3 is irrational, it's messy. So now on the bottom we have 3 and we have 2 root 3's. Well, that's the same thing as root 3 squared, which cancels. That's why that works. So we're going to get that this cancels to 3. So we have 1 3 times another 3 is 9. And on top there's stuff. That is the rationalized version of that. You're looking at it funny, Miss Lawrenson. Where are you stuck?
No, I'm just
You sure? Okay. So remember, this is just canceling, so you get this 3 times that 3 is 9. Okay, you can even do this if you want. Okay? Or you can write another step. It's up to you. All right, let's see if we need to rationalize this one. I don't know. Maybe, maybe not. You're saying no already, Cole? Why are you saying no?
This is 8x to the 1
If we need to rationalize, that's going to happen on the bottom. So let's do the bottom first.
So it's
5 square root of x squared is x. No square roots left, so I think we'll be good. No rationalizing this time. On the top, we get 8. It's the square root of 64. What about this?
You could do
Either in your head or on paper. Remember, you want to think of it like that. So you get square root of x to the 4th cancels 2 times. And then there's a root x left over. Now there's no root on the bottom this time, so we don't need to rationalize. Rationalizing is only the process to get rid of roots on the bottom. And that comes from, it applies to trigonometry, or I wouldn't teach it to you. But it came about because people didn't like dividing by things that were irrational, like pi. Like, how do you divide by something that has no ending and that doesn't repeat itself? It's really a mess if you don't have a calculator. So anyway, final answer is right there on that one. Okay, let's look at this guy and we'll call it good for today, I think. So we'll see if we need to rationalize it. We'll do the bottom first. So notice, these problems all had a big square root, and we thought about the top and bottom separately. These ones explicitly have the top and bottom in separate square roots. Could you rewrite this as one big square root with everything inside? Yeah, I mean, that's what we've been doing the whole time. You can. That's a property of square roots. They allow you to either write them separately or just as one big one. So yeah, so we're doing it separately now. Same thing. Okay. So square root of 12 doesn't come out nice, but 4 and 3. This will come out nice, so I'm going to leave it alone. How about the m's? What should I write for that? Can you guys help me?
10 ends and
Then 1 left over. Right. And then up on top, how about 48? 16, nice. 16 times 3. That might be one for your calculator if you're not getting that right away. Test 48 with 16, you'll find it is 3. Anyway, so then we're going to say a to the
6.
m to the 6th is ready. So you can see we're going to have some leftovers on this one, so let's just find out what's left over. So 16 becomes 4, left over 3. How many a's are going to come out? 3. Or really, it's a cubed, right? So if you say it technically correct, it's a cubed that comes out, but I don't know. There's 1 left over. How many m's will come out? M times m times m, or m cubed? There we go. I think the bottom's going to be similar. So 2, left over 3. A squared is going to come out, a times a, 2a is good. And m to the 5th. We have a leftover m. Okay? That's looking kind of ugly, but if you just think about it one piece at a time, it's not that bad. So don't let it intimidate you. So let's try to simplify. I think it needs to be rationalized because of this. but I'm not going to rationalize it yet. I'm going to see if I can knock anything out. Does anything cancel out or anything here? I think stuff does. What does? This becomes 2. 4 over 2 is 2, right? Gone. 1 is left over. You don't have to show your work like this if you don't want to. Well, these are all gone, right? And how many are left down here?
2.
2 of them, okay. And then there's some different options we have at that point. Let's write it out. Think about our options. We got a 2 on top. Got 1A on top. Gone 2 M's on the bottom. Then we've got this stuff. Okay, so there's 2 options at this point. You can think like this. This is my favorite option. Square roots break apart like this. You guys did that last time, I think. So it should start. When didn't we do that? Where we had, if they were like that you could put them together or break them apart, just like I talked about with the quotient. You can either put them in one big radical or split them apart into small radicals. Why would you want to think like this?
Cross off the 2's.
Yeah, exactly. You can cross those off now. And then we have a little bit simpler problem. Unfortunately, it still needs to be rationalized because I've got root m. So you guys tell me, how do I get rid of root m? Clever one. So this one's going to become m squared. Root m times root m is the square root of m squared, which is m. And then up on top we have 2a, and we can put these back together inside 1 if we want. So this is all, the point of this is all to get you used to and have practiced some stuff with square roots, because that's very useful later on. So I think our last simplification is we can say how many m's are really down here?
M cubed.
Yeah, exactly. That is the final answer to that problem. Now, there were different things I could have done. I think that I showed you a lot of tricks that you're going to need on some of yours. So, okay? So try out those now.